So this is a video going over KSP calculations, determining if a precipitate forms, and also talking about how to dissolve a precipitate and ensure or make a precipitate. So this next question on your lecture here is looking at will a precipitate form if you have 30 mils of a 0.01 molar aluminum chloride is mixed with 60 mils of a 0.003 molar sodium hydroxide. And for these types of problems, again, you're going to be given a KSP. So obviously we are going to look at the making of aluminum hydroxide. So I have a 1.3 times 10 to the negative 33 as my KSP. So this is the precipitate we are looking at. Now look at that number. Okay, that number is really telling you that this does not dissolve very readily. So if you get stuck on the AP test and you run out of time or something and you get to this problem, if you look at that power of 10 and you say, oh, I probably don't have, this does not dissolve very readily, and I probably don't need that much of aluminum and hydroxide in order to make that precipitate. So you could probably say yes without even doing the calculations. I don't know if they're going to allow that, but that's definitely one thing you could look at. So I'm going to figure out how much aluminum I have and how much hydroxide I have. So I'm going to figure out the aluminum ion concentration. So I have 0.01 molar and I have 0.03 liters. So I'm going to take the 0.03 liters and multiply it by 0.01 molarity. And I'm going to divide this by the total volume. So I'm mixing 30 mils with 60 mils. So we've done a few of these calculations along the way. So I have 0.09 liters of the solution. So when I multiply that all out, I get 3.3 times 10 to the negative third as my molarity of my aluminum ions. Now I could do the same thing for hydroxide. So I have 60 mils of it, and I have that concentration. So I'm going to take 0.06 liters and multiply it by 0.003 molarity. And again, the total volume is the 30 plus the 60 milliliters. So that ends up being 2 times 10 to the negative third molarity. So we have a KSP. This is aluminum ions times hydroxide ions, and that's going to be to the third power. That's going to be to the third power. So I'm going to take my aluminum, 3.3 times 10 to the negative third, and I'm going to multiply it by the hydroxide, which is 2 times 10 to the negative third, and I'm going to cube that. And when I multiply that all out, I get 2.7 times 10 to the negative 11th. Okay, so again, this is a Q calculation, meaning I need to know whether or not I make a precipitate. So that is the same calculation as a KSP. But since the Q is greater than 10 to the negative 33, which is my KSP value, I will say yes, a precipitate will form. Okay, and that's pretty standard for most of these types of problems, okay? You have to find the concentration of both of those ions, plug it in, and see if it's bigger or less than the KSP. So the next part of your notes on the bottom there has a section on how to dissolve a precipitate and then to how to make a precipitate. So these items I did not give you in your notes, so you need to copy them down. So we are talking about a solid breaking up into ions. Okay, so we are trying to figure out how better to essentially dissolve that solid. That's what we're looking at. So of course, one of the ways you could do that is by increasing temperature, because we know as we increase temperature, we will get more solids to dissolve. Okay, so that's a pretty standard one that you would think of. Changing the solvent, again, if it is a polar thing, we would want to include it in a polar solvent. If it is non-polar, then we would look at a non-polar solvent and see if it dissolves better. So again, most of the solids we're dealing with are ionic, so polar is going to be the way to go, but maybe you have something that is non-polar, you could also look at it that way. pH, I mentioned this before. So adding H plus or OH minus to a solution. So something like the precipitate we just looked at. So aluminum hydroxide. As that dissolves, it breaks up into aluminum and hydroxide. So if I have the hydroxide over here on the right-hand side, if I add H plus to that, it's going to remove that OH and push this equilibrium to the right. So you will get more of this solid to dissolve if I added it more acid and changed the pH. The other one that we didn't really talk about are carbonates. So something like sodium hydrogen carbonate. If I add this is going to be releasing an H and acting like an acid. So if I add an acid to this, I will get the CO2 to come out, and you would see that this actually will dissolve more. And complex ions, again, the cool thing about complex ions is they are aqueous. So you can get more things to dissolve if you put in something that forms a complex ion. So essentially what you're doing is removing an ion. So for example, if I have iron and I add thiocyanide to it, I will make the complex ion that I showed you before. So if I want to get more of a solid to dissolve, I can make a complex ion with, say, a chloride and remove the iron from that. So again, complex ions are not really going to be on the AP test that much, but it is another way to dissolve a precipitate. And how do I make a precipitate? Well, you could kind of look at everything kind of in reverse as to what we just talked about. So we could talk about decreasing the temperature, changing the solvent pH, and adding a common ion. So again, decreasing temperature, again, most solids, as you decrease temperature, you're going to see that less solids dissolve. Changing the solvent just like before, polar versus nonpolar. pH, again, if I add more OH to this equilibrium, I would get it to go and make more of the solid. So that would be how you could change the pH. And then adding a common ion. Okay, so that's the one I really want to talk about because that's the one we have focused on quite a bit in this chapter. So if I take lead 2 chloride, it's at equilibrium with its lead ions and its chloride ions. Aqueous, aqueous. If I want to have it go towards the left, so I want to shift that equilibrium to the left, what I want to do is increase these ions in order to make more of the solid. So I could easily add a sodium chloride solution, would add the chloride ion to this equilibrium. And so I could get that to stay more in the solid rather than breaking up into the aqueous.